Hi, my name is Andy Thay. I'm a Senior Field Applications Engineer with Interval Zero. And we're going to be here to talk to you today about how to maximize performance out of a Windows-based system, at the same time extract all the performance you can out of the x86 cores below. And the way we're going to do that is by implementing something called Simmetric Multi Processing through a soft control architecture. So in the next couple of minutes, I'll go through some diagrams to help illustrate that point. Okay, now, so I'm going to illustrate what your current system looks like today. So here's a Windows. Here's your x86 platform. And we're going to select a dual core architecture. You have your scheduler down below. And you have your different applications. Here you have your user interface. So this is like app 1. And then over here you have your time-critical routines or CPU-intensive app, and that's sitting over here, app 2, so we'll put real time. And so what happens in the system you have now is you have your complex interface, you have your real-time processes and threads, and you actually come to what we consider more of a bottleneck. This is the Windows scheduler, and it's working pretty well, and it's trying to schedule things to each core as fast as it possibly can. So for some systems you get satisfactory performance. For a lot of people this is kind of a compromise, because you actually need to somewhat protect this, and to get the most out of Windows and your real-time subsystem, some people have to go to more as far as extensive lengths. So what some people do to get more performance is they actually create another subsystem here with actually a different device. So this can be something like a DSP, this can be like an FPGA, and they actually move this app all over into this subsystem. So here's now your app 2 real-time portion, and we'll move it out of here. And then of course there's going to be some sort of RTOS or some sort of scheduler that's there, or it's going to be done in hard logic. So now we actually created a hybrid system, and now you're able to get the most out of Windows, because now anything you have related to Windows and the UI is all as far as scheduled through one scheduler to its cores, and then over here you have anything time critical scheduled to specialized hardware and through an operating system. Now it's a little more complex though. Now you're talking about two different devices. You're talking about Visual Studio C++ over here. Now you're talking about a different proprietary tool set over here. Now you're talking about a different code base, you're talking about a different operating system. And then also communication becomes an issue. So although we've extracted a lot of performance, now we've got to take some compromises into account, because communication's an issue, as well as having different development teams, different architectures, different code bases, and actually a more complex board design because you have multiple devices. Okay? So now let's move over. And let's see how we can now implement SMP, or soft control architecture, to the same system. And so let's redraw it. Here again we still have our x86 platform, and here we'll actually select a quad core, because that's becoming pretty standard. You still have your Windows. Here's your Windows scheduler. And then you still have your user interface, which is app 1. But now, under SMP, a version of soft control, we actually have real-time extension, or a secondary scheduler, in place. So we'll call this space the RTX. That's the name of the product. And there's an RTX scheduler, a microkernel here. And so now you can have your real-time app and processes here. And the beauty now is you actually have a parallel world. You actually can have the UI talking directly to the Windows scheduler, and then it being allocated and run on the cores that are associated with Windows, while you can have the real-time application and threads going through the RTX scheduler, which is an extension of Windows, and it will schedule things to its associated or dedicated cores. And one of the really nice benefits is you actually have very nice communications between these two as far as subsystems, because you can actually import and export the different API sets towards one another. So it really, if you look at this, you're actually extracting the most you can out of Windows by dedicating the hardware and a scheduler to that system, and in the real time or the time critical piece, you've done the same thing. You have a parallel scheduler in place, you have dedicated cores, real-time processing, excellent communications, and I should point out too, all of this is under the same development environment. So quite a change here. Now we've actually simplified your development environment, standardized around a single code base, all on x86 cores, so your platform is the same, and it's almost like we've created two devices in one. So actually your board costs will go down, simplifying the overall system. So hopefully this can show you how you can translate going to a soft control SMP architecture. We can help reduce your system costs, speed your time to market, simplify your development environment as well as your development teams, and hopefully overall bring you a better solution to market. So in conclusion, I know we've covered a lot of ground, a lot of topics in a short amount of time, but hopefully that gave you sort of an overview as far as how a soft control SMP environment can really extract the most amount of your Windows system at the same time giving you true deterministic processing and taking full advantage of the x86 architecture. So if you have further questions, which I'm sure you probably do, please contact me, and my email will be at the bottom of the screen, is andy.the@interval0.com. So thanks again for tuning in, and I look forward to hearing from you.